Okay, so I am looking on page 80 of your book. And on page 79 of your book, at the very bottom, there is a formula for the cardinality number of the union of finite sets. And it basically says the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. And later on, when we start doing probability theory, this is going to be important because we're not going to want to repeat uh, information or repeat certain elements. And when we start doing permutations and combinations, I think later in chapter 11. But okay, this is a formula you're going to be using for some applications. And so we're going to do checkpoint 8 in your book. All right, it's right below example 8. And it says, according to factmonster.com, among the U.S. presidents in the White House, 26 had dogs, 11 had cats, and 9 had both, okay, dogs and cats. How many U.S. presidents had dogs or cats? Okay, there's a given and there's a goal. What is the given information? What do they give us? Well, let's see, among U.S. presidents, okay, so let's label a couple of things. We are going to let A be the set of, let's see, U.S. presidents such that, let's see, well, let's say U.S. presidents. Well, we don't technically have to, we don't have to write it in set builder. We can write it in just a word description without the set builder notation. So let A be, okay, the set of U.S. Presidents with dogs, or that had dogs, that had. And let's set B be the set of U.S. presidents that had cats, right? Only dogs and only cats. And then finally, well, we know from the given information that the intersection of A and B, well, how many U.S. presidents had dogs and cats? Well, I'm just looking at your on page 80, and it says 9 had both dogs and cats. So, well, we can do this too. Set of U.S. presidents with both, right, dogs and, that's an and cats. Okay, so we have using the formula, it's, well, the question asks, how many U.S. presidents had dogs or cats in the White House? Key word is or, and let's see, right, that union means or, and this intersection literally means and. Okay, so let's go back down, and if we use the formula, let me get this go up. Actually, I did want to write something else right here. Okay, so this is set A, so then what's n of A? What's the cardinality of A? Well, according to how many had dogs, it was 26, right? A is not 26. N of A is 26. Right? Because A could be, again, this can be, you know, 1 president, 2, 3, right? All the way to 26 presidents. And you're telling me the cardinality of that set. And N of B looks like, oh, was N of B had 11. And then the cardinality of both cats and dogs is, looks like, what was it, 9, I think. And again, if you want to call this C and D for cats and dogs, that's fine. I'm just using A and B. So finally, the question is asking for this guy right here. So N of A union B is n of A plus n of B minus n of A union B. And move, whoops, that's not my eraser, but okay, let's just move up. And again, we're just filling everything in, right? N of A is 26 plus N of B, it looks like 11. The intersection, and 26, 36, 37. 37 minus 9 is 28. So the number of presidents that had dogs or cats in the White House was 28. And that's pretty much it. That's an application. It's one of the simple applications. Okay, so this is the last application. Or the last example. It's a long section, but well, it's not going to get any easier. It's again, it's we're moving on to other chapters.